Second, kinematics. Acceleration. Rate change of velocity called acceleration. When velocity is increasing, so velocity must increase. It is denoted by A, and A is V2 minus V1, T2 minus T1, V1 velocity in time T1, V2 velocity in time T2, or it is dV by dt. Small velocity, difference, small time. So this is what acceleration, rate change in velocity. We have already read it up to metric. Retardation. Rate change of velocity when velocity is decreasing, called retardation. It is denoted by minus A. That is, minus A is again same, dV by dt. Units of acceleration or retardation. SI, meter per second square. CGS, centimeter per second square. Dimensions. V by T, S by T square, S by T square, dimensions. Uniform accelerated motion. When acceleration of object is constant, then motion called uniform accelerated motion. Dictionary definition. This is main definition. V T 2 meter per second, 1 second, 4 meter per second, 2 second, 6 meter per second, 3 second, 8 meter per second, 4 second. Increase 2 meter per second. In 1 second, the acceleration is 2 meter per second square. Increase 2 meter per second in 1 second. Acceleration V by T 2 meter per second, 1 second. Acceleration here it is 2 meter per second square, 2 meter per second. So this is what? Uniform acceleration. So motion is uniform accelerated motion. So this is main definition. When velocity of body increases by equal amounts in equal time intervals, then motion called uniform accelerated motion. So this is what something about acceleration. Plot. VT graph of uniform accelerated motion. Show slope of graph is acceleration this is a question. So first make table. What is the graph? VT graph. Make table velocity and time. Write one velocity, say it is 2 meter per second. 0 second. Increase velocity, say it is 4 meter per second. 1 second. The increase is 2 meter per second. Then same increase, 2 meter per second in 1 second, 8 meter per second in 3 seconds. One second. So the acceleration is constant. So uniform accelerated motion. Uniform accelerated acceleration. So then plot the graph. This is T. This is V. V is in meter per second. T is in seconds. 2, 4, 6, 8. It is 2, 4, 6, 8. 0, 1, 2, 3. 0, 2, 1, 4, 2, 6, 3, 8, this is graph. Plot VT graph. This is what? VT graph. The graph is straight line. Inclined to time axis. This is time axis. It is making certain angle with time axis. It is making certain angle with velocity axis. You can say the graph is straight line inclined to velocity axis. Now slope of graph. Slope, ये slope है. This one is what? Slope. ये plane है. Slope. Draw two parallel lines. Let this be A. This be B. Parallel to velocity axis. Draw another line parallel to time axis. This is what? T1. This is what? T2. This is V1. Velocity theta. This is what? V2. This is that slope. So slope always tan theta BC by AC. BC, it is V2 minus V1. It is T2 minus T1. It is what? dV by dt. It is what? A. Hence, slope of graph is acceleration of uniform accelerated motion. This is differentiation. This side integration. Idea about differentiation and integration as it will be used further. ddt differentiation with respect to time. ddx differentiation with respect to position. ddv differentiation with respect to velocity. ddx 3x5 rule, take constant outside. ddx x5, only x is variable, other things are constant. Here m, k, y, जो कुछ भी कोई भी है x से अलग, that will be constant. Now differentiate x5, take power to side. Subtract 1 from power and then ddx x. So it is what? 15. dx by dx is 1. x4. ddx 7x cube, 7 outside, take power to side, subtract 1 from power, then dx by dx. So ddv लिख दिया इस बार से 2v square, constant outside, take power to side, subtract 1 from power. ddx x 1, take power to side, subtract 1 from power. ddx 3 ddx 3x naught, it is 3. Constant outside, take power to side, subtract 1 from power. That is ddx of any constant is 0. Differentiation of any constant is 0. So this is a rule for differentiation. Brief about differentiation. DDT, differentiation. This word for differentiation, this word for time. Differentiation with respect to. Differentiation with respect to position. Differentiation with respect to velocity. Now this symbol, integration. With respect to position. Integration with respect to time. Integration with respect to velocity. Integration 15x4 with respect to x. Integration with respect to x. Whom? 15x4. Take constant outside. Constant outside. Integrate it. Add 1 to power. Divide by same power. It is what? 3x5. x square. Take outside constant. Add 1 to power. Divide by same power. Differentiation 3x5, 15x4. Integration 15x4, 3x5. Differentiation 7x cube, 21x square. Integration 21x square, 7x cube. Reverse. V dV. 4 is constant. Add 1 to power. Divide by same power. 2v square. Differentiation 2v square 4v. Integration 4v. One x0 dx. Add 1. It is x. Differentiation of x was 1. Integration of x 1 is what? X. Integration y. Differentiation of constant is 0, so integration of 0 is constant. Check the rule again. Equation uniform accelerated motion. V u plus at as ut plus half at square v square u square 2as snth u plus a by 2 2n minus 1. These are equations of uniform accelerated motion. We already know this is initial velocity, this is final velocity, this is acceleration, this is time. This is distance, initial time, acceleration. This is distance traveled in nth second, initial velocity. This is that nth second n. So these are equations of motion of uniform accelerated motion. We know these things: dx by dt, a dv by dt. First, derive v u plus at. ये भी चाहिए ए, इससे काम नहीं चलेगा, ये लीजिए. We know a dv by dt, a dt dv. Integrating it within limits a dt dv, integration within limit of variable. Time is variable. Look how many times. One is t. This is time of this velocity. This means this time for this velocity is 0. 2 times should be there. One is seen here. This is t. This time is of velocity v. So time of this velocity u, initial velocity है, तो initial will be 0. Lower, higher. Velocity variable. 2 velocities should be there. 0 time u, t time it is v. So this is what integrating this equation within limits. A constant outside dt 0 to t, dv 0 to v. A dt it is what t0. It is t0 dt. So what? Add 1 to power, divide by same power. dv, it is v0 dv. Add 1 to power, divide by same power. Power is 1. How to apply limits? A is a, value of t is t, माइनस फार्मूला है लिमिट लगाने के लिए, वैल्यू ऑफ टी इज 0, वैल्यू ऑफ v इज v माइनस वैल्यू ऑफ v इज u. It is 80, it is v minus u, it is v, take this to this side, u plus 80, hence derived. तो हमने क्या इनमें से एक लेके चलेंगे, ये जो भी डिराइव करेंगे ये. अब अगला डिराइव करेंगे ये s डिस्टेंस, ये नहीं लेकर चल सकते, है ही नहीं डिस्टेंस इसमें, तो ये लेके चलेंगे ये. Derive x naught ut half at square. We know v dx by dt, v dt dx, we have done v, u plus at dt dx, u dt at dt dx. Now this equation is ready for integration. Integrating it within limits. Constant outside, टाइम की लिमिट, दो टाइम होंगे, इनिशियल फाइनल. कांस्टेंट आउटसाइड, यहाँ टाइम वेरिएबल है तो ए इज कांस्टेंट. 2 times initial final. 2 distances, one is x 0 time, other is x t time distance. Now this is t0 dt, so t a, add 1 to power, it is what x, it is u, it is 0 to t, t minus 0, a 2 outside, value of t is t, square is there, value of t is 0, square is there, value of x is x minus, so it is ut plus half at square x minus x naught. Take x naught to this side, x naught plus ut plus half at square. Hence what? Derived. Derive v square minus u square 2as. Instead of us say this one. ये क्यों लिया? डायरेक्ट डिस्टेंस निकालना था तो डिस्टेंस लिया, यहाँ डायरेक्ट डिस्टेंस नहीं है तो बड़ा ही लेके चलोगे आप, a dv by dt. We know this thing. लेकिन डिस्टेंस तो चाहिएगा हमें, तो करिए dv by dt डिस्टेंस से मल्टीप्लाई करो, इक्वेशन ना बदले, डिस्टेंस से डिवाइड कर दो. इट इज dv by dx, पहले लिखा है मैंने, dx by dt. It is a dx by dt. It is dv by dx first. Dx by dt is what? V. V is dx by dt. Or a dx v dv. Now this equation is ready for integration. Integrating it within limits. A dx integration v dv integration limit. Who is variable? This is variable. Velocity is variable. There are two velocities, u and v, lower, higher. Two distance. For u initial velocity, it is x naught, x. A outside constant. A is a dx is x 0 dx, add 1 to power, divide by same power, add 1 to power, divide by same power. Value of x is x minus formula है लिमिट के लिए, value of this is this minus value of this is this, value of v is v, square is there by 2 minus value of v is u, square is there by 2, it is 2a x minus x naught. 2 LCM इधर ले आए हम, v square minus u square, hence what? Derived. No question. Let a body travels a distance 10 meter in 6 seconds. 14 meter in 7 seconds. Then distance travel in 7 seconds only, that will be 4 meter. 10 meter in 6 seconds, 14 meter in 7 seconds. So in 7th second the distance will be 4 meter. That is what? S7 minus S6. Snth 4 meter. Sorry, S7 second it is 4 meter. कहाँ से आया ये? इसमें से ये सब्ट्रैक्ट कर दिया. So Snth S7 instead of 7 Sn minus 6, 1 less. No question, just what will be Snth, Sn minus, एक कम, Sn minus 1. This is distance traveled in n seconds, this is distance traveled in n minus 1 second. Derive expression for distance traveled in nth second, or derive Snth u a by 2 2n minus 1. This is our question. तो Snth निकालना क्या चाहिएगा हमने? Sn distance in n second, distance is n minus 1 second. We know distance traveled in time t, s ut plus half a t square. A small t लिख दो यहाँ एक. This will be what distance traveled in time t. What I need? Time n. If t is n, putting it in first, Sn un half an square ये निकालना है, ये चाहिए था. अगर if t is n minus 1, putting it in first as n minus 1 ut n minus 1 half a t square, half a t square t, it is un minus u, it is half a n square, open the bracket, 2n it is un minus u half a n square half a minus half a 2n. We know. What we know? Snth, Sn, n minus 1, Snth, Sn, Sn from second, in second there is Sn, un plus half an square minus Sn minus 1, थर्ड में है ये, माइनस करना है, माइनस ये Sn माइनस 1 को माइनस करना है, तो सारे साइन चेंज कर दो, माइनस un प्लस u माइनस हाफ an स्क्वेयर माइनस हाफ a प्लस हाफ a 2n. ये माइनस करना था, सारे साइन चेंज कर दिए हमने. un goes with this un, half an square goes with this half an square. What is left? U plus half a 2n minus half a. U, it is a by 2. It is 2n minus 1. Hence what? Derived. So these are derivations of equations of motion of uniform accelerated motion.